This lecture focuses on weathering and erosion of rocks. First, let's start out with the definitions. Weathering is a process that breaks rocks into smaller pieces. Wind, water, ice, and gravity can all do this. Erosion is the movement of weathered material. So weathering breaks down rock, erosion moves it. Chemical weathering is due to chemical reactions. Some examples would be rust and acid rain. Acid rain is responsible for making tombstones look faded. Over the years, every time it rains, the acid rain will slowly dissolve away the limestone. Rust is another example. Here, the metal will react with the oxygen in the air when it gets wet and turn to rust. The Statue of Liberty is copper. However, the copper is reacting with the moisture and the oxygen in the air, and it is turning into the mineral malachite, which is green. This is another example of chemical weathering. Mechanical weathering is weathering through physical force. Two examples are freeze and thaw and wind. Here's an example of freeze and thaw. When it rains, water may get down into the cracks of rocks. At nighttime, when the temperature drops, that water will turn into ice. Ice will actually expand, so it expands the rock and breaks it apart. Roots can do the same thing. Roots of trees can get down into the cracks, and as it grows, it will expand the rock and cause it to break. This is an example of wind weathering the rock. When wind blows across the desert, it'll pick up little pieces of sand, and it will hit the rock that's standing up here and weather it away. Wind will blow sand near the ground. So near the ground is where you're going to get the most amount of weathering. There's not going to be a whole lot of sand blowing up higher, so that doesn't weather nearly as fast. Here's another example. This is actually caused by water. This is called a slot canyon, and these canyons can get up to 1,000 feet high. Here's an example of size. That's me, and that's my mom in the background. And we're standing in these slot canyons out in Arizona. It's very dry out there. When it rains, the water will flood into this canyon and get maybe about 50 feet high. As that water is rushing through the canyon, it will carve out the sandstone. Here's another example of how big these canyons can get. This is actually the same canyon, only in a different area that has opened up. To give you size, here I am standing here at the bottom. And this was maybe about half the canyon, so there's another half above the picture. Here's another example. This is Half Dome out in California in Yosemite National Park. Half Dome is a mountain made of granite. This was once a batholith which was magma that has cooled down and formed the granite. Now this formed deep inside the earth. Now it's on the surface, so now it's under a lot less pressure. This is causing what's called exfoliation. If you look closely, you see it looks like it's peeling off. Here's another example of it peeling off. Natural arches can also form through erosion. Arches will typically form at the wall of a cliff. This happens when the rock layer below the arch itself will erode much faster than the arch. Therefore, the layer below the arch will fall away from the cliff, and that will leave behind the arch. The rate, or how fast something's going to erode, will depend on the element doing the eroding. So in other words, how fast the water is moving, or how slow the water is moving, or the wind, etc. The faster the element is moving, the more sediments it can hold. So think of a raging river. That's going to be able to hold a lot more than a little trickle of a stream, or even a pond. Go to the extreme where there is no movement. That won't be able to hold anything. Now here are some examples of how fast the media is moving will depend on the rate of erosion. In this picture, we've got a big pile of sand, and behind there is a big mountain. What's happening is the wind is blowing across the desert, picking up sand, but as soon as that wind hits the mountain, it slows down because it now has to go up the mountain. So when the wind slows down, it drops all the sand it's carrying, and over the years, you get a big pile of sand. This is the Great Sand Dunes National Park. Another example is at the beach. Did you ever notice how at the beach you have these fences with slits in them? The reason for that, when the wind blows across the sand, it picks it up. Did you ever notice if you lay on the beach, you might feel sand hitting your face? That's because the wind is blowing sand near the ground. When that wind hits the fence, it has to slow down to go around these slits. When it slows down, it's going to drop the sand, and that will preserve the sand dunes. The sand dunes are very important for the communities near the beach because the sand dunes will protect the community from big storms that would bring high seawater. Here's an example of river. This is the Mississippi River coming down, and the river next to it is the Atchafalaya River. These rivers will bring a lot of sediment down. A lot, mostly silt and clay and some sand. Once that river reaches the ocean, it's no longer flowing downhill, so the velocity or the speed of the river slows down. Once it slows down at the ocean, it's going to drop all the sediments that it's carrying. So we get this fan-like feature called a delta. An interesting side note is the Mississippi River actually wants to move over to the Atchafalaya River. But humans don't want that because New Orleans is located right here, and the Mississippi River is a huge area of imports and exports. So a lot of ships will go all the way up the Mississippi River to deliver goods. If the Mississippi River starts flowing down the Atchafalaya River, New Orleans will become a dead town. There's not going to be a lot of money in New Orleans. So what we did to protect New Orleans is we built all these levees. But the Mississippi River is constantly, every day, every night, every second, is bringing down sediment. So the bottom of the river is actually raising up. So we have to raise our levees up. Well, when Katrina came through, it broke our levees, and the water flowed downhill and flowed down into the city. I have an acquaintance that actually lives in Mississippi in New Orleans, and he lives on the 5th floor of an apartment building. And on his apartment building, he is almost level with the Mississippi River because it is actually much higher than the actual town. So in the previous slide, I was talking about how rivers will deposit or lay down the sediments. Here's how they might erode. When a river is going around bends, the outside of the bend is going to be moving faster than the inside of the bend. The reason, it has to go here in the same amount of time. However, the outside of the bend is going to go a greater distance than the inside of a bend. Imagine me standing with my arm held out, level to the floor, and I start to spin. Think about my shoulder versus my fingers. Which one's going to be moving a greater distance? My fingers will move a greater distance because they're farther away from my body. So my fingers are going to move a greater distance in the same amount of time that my shoulders will. Therefore, my fingers are going to be moving faster. So since the outside of the bend is going to be moving faster, it's going to erode. So in other words, it's going to pick up sediment and take it away. On the inside of the bend, it's moving much slower, so any sediment that the river is carrying will be deposited, so it's going to lay it down. So over time, this bend in the river migrates. Over more time, these two sections will connect, and now the river will flow this way, and this creates an oxbow lake. This becomes interesting. Imagine this is the Rio Grande River. Imagine this side is the United States. Imagine this side is Mexico. Pretend you have a house right here. Right now, that would be a U.S. land. But over time, now the house is considered to be on Mexican land. Okay, here is an old river going back and forth, back and forth. I actually took this picture out of an airplane. So old rivers are known to meander, going back and forth, back and forth. They don't move very fast because there's not a very high grade. A middle-aged river, again, another picture I took from the airplane, it moves back and forth, but not quite as much. And you can see On the inside of the bends, how you have a buildup of sediment. That's because it's moving much slower. And a young river is typically going to move very straight. It's typically going to be a little bit more rocky, and it's going to move faster. Typically, wet climates are going to have a faster rate of erosion. Water will do a great amount of erosion, so wet climates will have a lot of erosion. Drier climates will too, and also cold climates. Factors that can cause erosion are wind, glaciers, gravity, and water. And deposition is when sediments are deposited or put to rest, so they stop moving. So I talked about wind and water a little bit. Now I'm going to talk about gravity. Gravity is the attractive force between all objects. So since the Earth is very big, very massive, it's going to pull a lot of the small things here on Earth towards the center of the Earth. Mass movement. This is gravity causes loose material to move down the slope. So gravity is just pulling stuff down the hill. Here are some different types of mass movement. First we have slump. Slump is mass movement when loose material or rock layers will slip down the slope. So you'll get sort of this step-like pattern. Creep is when sediments move slowly down the hill. So it creeps down the hill very slowly. This is evident when you have telephone poles leaning. You'll see tree trunks curve at the bottom, or you'll see uneven fences. This is all caused by creep. So creep is much slower than slump. Both types, however, are fairly slow. These will happen over a period of years or decades. Here are two other types that are much faster. Rock slides are large blocks of rocks break loose from a steep slope and they tumble down. So here's an example of a rock slide. Mud flows, this occurs usually in dry areas that doesn't have a lot of vegetation. When it rains, this creates a lot of mud very quickly and it flows down the slope. California is very well known for having a lot of mud flows. Here's just a diagram that puts it all into perspective. Up here we've got rocks. As the velocity increases, we get different types, such as rock slides, rock falls, or avalanches. Here we've got dirt. Again, velocity is going to increase, so we can have creep, we can have an earth flow, or we can have a debris flow. I mentioned mud flows. We have slump again, debris slide, and debris avalanche. This concludes our lecture on weather and erosion.